Good morning, student. We'll begin with lecture number 25, Simple Stress and Strain, Numerical Stresses in Composite section under axial loading. In our previous lecture number 24, we have solved two numerical. We will solve two more numerical in our today's lecture. Numerical 1. A steel tube 40 mm inside diameter and 4 mm metal thickness is filled with concrete. Determine the stress in each material due to an axial thrust of 100 kN. Take modulus of rigidity, modulus of elasticity for steel. ES is equal to 2.1 into 10 raised to 5 Newton per mm square, and EC, that is modulus of elasticity for concrete, 0.14 into 10 raised to 5 Newton per mm square. Given internal diameter D is equal to 40 mm, thickness T 4 mm, P 100 into 10 raised to 3 Newton, capital D external diameter is equal to 48 mm. We'll first draw the figure. This is the figure. Between you have got, in the blue color is completely concrete filled, and outside is the steel tube. These are the details. Now, the previous problem which we have seen in lecture number 24, everything is the same except the load is being changed. The load is changed over here. Yes, external diameter 48, internal diameter 40, thickness T 4 mm. Concept here we will be using this way. First step to find area, the second to find stresses in section, and third load on tube. These are the three formulas, three concepts we will be using. So let's solve the problem. Solution. Area of steel and concrete. Step 1. Determine cross-sectional area of steel tube and concrete filling. Area of steel tube AS is equal to 4 pi D1 minus D2 is equal to 4 by pi is equal to pi divided by 4 in bracket 48 square minus 40 square bracket close is equal to 552.92 mm square is the area of steel section. Now the area of concrete section, pi divided by 4 into 40 square is equal to 1256.63 mm square. The concrete is filled completely here inside, that is D, that is 40, and then external is 48. Step 2. To determine stress in each material. Let stress in steel is equal to sigma x, stress in concrete is sigma c. Formula sigma s divided by ES is equal to sigma c divided by EC. Solution. Sigma s, by rearranging we get sigma s is equal to ES divided by EC into sigma c. Substituting the value and solving, we get sigma s is equal to 15 sigma c. Now load P is equal to load on steel PS plus load on concrete PC, which is nothing but PS is nothing but sigma s AS, that is stresses in steel into area in steel plus stresses in concrete into area in concrete. When we substitute the value, this is equation 2. Now substituting the value of sigma s from equation 1 in equation 2. In equation 1, sigma s is equal to 15 sigma c. We substitute that value in sigma s. So we get 100 into 10 raised to 3 is equal to 15 sigma c into 552.92 plus sigma c into 1256.03. So while substituting the value and solving, we get sigma C is equal to 10.47 Newton per mm square. Now we have to find sigma S. We know that the value of sigma C in equation 1 is equal to sigma S is equal to 15 sigma C. So substituting the value of sigma C in equation 1, we get sigma S is equal to 15 into 10.47. Sigma S is equal to 157.05 Newton per mm square. So this is the answer. Second numerical, a composite bar consisting of steel rod 30 mm in diameter enclosed in a copper tube of external diameter 60 mm and internal diameter of 30 mm. It is subjected to compressive axial load of 110 kN. Calculate stresses developed in steel and copper. Take ES, that is modulus of elasticity of steel, 2.1 into 10 raised to 5 Newton per mm square, and EC, that is modulus of elasticity for copper section, is equal to 1.05 into 10 raised to 5 Newton per mm square. So solution: D, that is diameter of steel rod 30 mm. External diameter of copper tube D1 is equal to 60 mm. Internal diameter of copper tube D2 is equal to 30 mm. Compressive axial load P is equal to 110 kN. We will first draw the figure. This is the figure. We have a copper tube outside, 11 number designated by number 11, that is copper tube indicated by number 11. Then inside the green part, that is with green cross line, it is completely steel. So in next figure you can see the inner part is steel rod and the external is completely copper tube. The diameter of steel rod 30 mm, that is D1 is equal to 30 mm, D2 is equal to 60 mm. Compressive force P shown by arrow acting from the both sides towards each other, P is equal to 110 kN. I hope the diagram is clear to you. Concept: first we have to find the area, then second we have to find the stresses, and what formula more is the load on tube. So using these three formula, step by step we will find out the stresses. First we will find out the area, then we will use the two formulas and we will find out the stress. Step 1. Determine cross-sectional area of copper section and steel section. Area of copper section AC is equal to pi by 4 into bracket D1 square minus D2 square bracket close is equal to pi divided by 4 in bracket 60 square minus 30 square bracket close. Answer 2120.575 mm square, that is cross sectional area of copper. Area of steel section AS is equal to pi divided by 4 into 30 square is equal to 706.858 mm square. So this is the area of steel, cross sectional area of steel and copper. Solution for sigma S and sigma C. Step 2. To determine stress in each material. Let stress in steel is equal to sigma S. Stress in copper is equal to sigma C. We get the formula sigma S divided by ES is equal to sigma C divided by EC. Sigma S rearranging, sigma S is equal to ES divided by EC into sigma C, which is equal to 2.1 into 10 raised to 5 sigma C divided by 1.05 into 10 raised to 5. Solving, we get sigma S is equal to 2 times sigma C. We know then other formula for load on the section is equal to P. P is equal to PS, that is load on steel section, plus PC, load on copper section. Okay, PS is sigma S, that's a stresses in steel, into cross-sectional area AS, plus PC, that is load on concrete, is equal to sigma C, stresses in concrete, into area cross-sectional area of concrete. We substitute the value and we name it equation 2. Now since there are two variables, we name it equation 2. So we have two equations, equation 1 and equation 2. Now substituting the value of sigma S from equation 1 in equation 2. We substitute the value, we get 110 into 10 raised to 3 is equal to 2 sigma C into 706.85 plus sigma C into 2120.575. By solving, we get sigma C is equal to 31 Newton per mm square. Now we have to find sigma S. So substituting the value of sigma C in equation 1, we get sigma S is equal to twice sigma C. Sigma C is 31. We put the value 31. We get sigma S is equal to 2 into 31. So sigma S, that is stresses in steel, is equal to 62 Newton per mm square. So this is for the day. Thank you, student.